can only imagine what you guys are going through week 6. You know, what appears to be a crazy fall term.
Yeah.
Yeah, this one seems a little exceptionally crazy based on my data that I've been collecting. It could be random fluctuations.
I've had the same experience.
Many students have, the ones that have told me. It could be random, it could be our randomly biased sampling. It could be that, I don't know. See the moon this morning? It could be the moon.
Yeah.
The moon was gorgeous, sitting behind the clouds this morning. You guys up early enough to see that? There was a bank of clouds coming in and a full moon was setting behind it. Oh. Made my neck stop hurting for a couple seconds. Then it started again. All right, so you've read something like this before. You've read something like this before. Whenever I read an article like this about, oh, it was so much better back when, and now things are going to hell in a handbasket because of, I always stop, take a breath, and then analyze. It's easy to knee-jerk react and go, shut up! It's much better to be able to put a metric on the shut up. Okay, so that's what we're going to learn to do today, is put a metric on the shut up. So, what's the problem? What's the problem in Florida from 1999 to 2009? Right, number of deaths from motorcycles have grown in record numbers because why? Careful, David, you're speaking like an informed American as opposed to a non-informed American. It's clear that people are dying more because why? I'm being the ignorant American now. Because we took the mandate of the helmet away. It's clearly killing more people. And as data they supplied in 2009, 402 motorcycle-related deaths occurred here, yes? Clear. It's clear to me that there is a problem. It's clear to me that in 1999, the Florida motorbike death rate was 0.000745. So, here. In 1999, the Florida motorbike death rate was 0.000745, which means 745 out of every million died in that year. Now that's extrapolated to a million. It might have been less than a million, maybe 500,000, or half of that, but that's the fraction, the probability of death in 1999. I don't know that in 1999 actually, Tyler. I didn't know that, so Tyler's got a very good question. How many were on the road in 99? I didn't know that. What I did know was that was the rate, and I couldn't for the life of me locate 1999's number. But I figured I got the rate, right? I got the rate, so at least I can compare the rate. So if I can't compare an average number, at least I can compare a probability. And Tyler brings up a very good point too. We're going to start talking about power studies, which is the strength of a result. We'll do another one right before the end of class today, which is we're going to have a very low power because of small sample size. Sample size is important, very, very important. And without having the known sample size, only focusing on a probability, you do sacrifice a little bit. But it's the best we can do with the data I've got. Fair, great question though, great question. Okay, so this paper, the Gainesville Sun, clearly has a claim, doesn't it? It clearly has a claim. It's telling me that the Florida motorcycle death rate in 2009 is what? What's its argument?
It's higher.
It's gotta be, right? I mean, look at that. 400 people died. It's higher than it was in 99, isn't it? Is that fair? Yeah, I mean, clearly, the claim of the Gainesville Sun is that the Florida motorbike death rate in 2009 has exceeded what it was in 1999. Over the course of a decade, that rate has skyrocketed. We are killing people off left and right, all because they're not wearing helmets anymore. Now, of course, this, as Brandon pointed out last week, at some point last week, correlation does not imply causation. Nobody's questioned whether these 400 people had heart attacks while they were riding the bike down the road. Nobody's bothered to check that. We're just making the assumption that more people are dying, they no longer need helmets, therefore, let me stop at that. So, anyway, the null hypothesis, of course, would be it's less than or equal to that. Fair enough? So we are once again looking at a curve. That curve is centered on the old rate, 0.00075. That's the old rate. That's the old rate. The claim of the Gainesville Sun is that where's our new rate?
To the right.
To the right of it somewhere, right? Our job is to test their claim. Our job is to support their claim. What the hell? Let's be positive. We're going to support the Gainesville's a cute town. We're going to support the Gainesville Sun's assertion that the rate is higher now. And then, once we've established that it's higher, we can go back and look to make sure, A, it was the helmets that were doing it, and B, it wasn't some random fluctuation in the system. Good so far? Make sense? Let's look at the two kinds of error before we get going. Now you guys are already hot to get in there and run your numbers, which I love. I love that you're crunching numbers already. We could be wrong either way, right? What would a type 1 error be? What would a type 1 error be?
That we said it affected the increased and it didn't.
Good. Type 1 error would be, yep, your rate sure is going higher, but we were wrong. It actually isn't. We got a fluctuation. Good. Type 2 error would be, nope. Rate's not higher, but it actually is. This is another one I personally would like to avoid a type 2 on, although since it's just a local newspaper making a claim, you can ignore both of them in reality. Nobody's going to live or die based on this claim. It's kind of just an ethereal claim. So a type 1 would be, yes, we do believe the rate is higher, but in fact it's not. And a type 2 is, no, we don't believe the rate is higher, but in fact it is. Actually, I could see either of those being bad. How would a type 1 error be bad? So saying the rate is higher when it actually isn't. How could that be bad?
Because people are dying.
You could eventually get the...
But they're not dying at any higher of a rate. So a type 1 error is saying they are dying at a higher rate, but they're not. So why would that be bad? Jake, go ahead.
It could get the helmet law reversed.
It might get the helmet law reversed, which would then piss some people off by saying, wait a minute, you're telling me I don't have to wear a helmet. Now you're telling me I do have to wear a helmet. Would you make up your mind? You see what I'm saying? You could take that type 1 error and institute something that is unnecessary technically. Good. So that's how a type 1 error could be a problem. A type 2 error is what you're talking about, Brian. So I can see how both of them would be bad.
More of a, people dying versus upsetting people?
No, I got you. I'm not trying to metric those, which one you think is worse. I'm just saying I can see how both could be considered bad. Right. I can see how both could be considered bad. Fair? You okay? All right, cool. So we're going to use an Z distribution. I think it's time to run the numbers. Brandon, at the risk of making you fall asleep, I'm going to turn the lights back off. Just because the resolution on the TI is not quite as good as I hoped.